got cubic graphs that we are drawing, sketching. You need all the nitty-gritty stuff. So to sketch this, and will it be asked like this in a test? If I have to give a guess, I would say no, I don't think so. Because they always give you some scaffolding. They say, find the x-intercept, then they say, find the y-intercept, they say all sorts of things. They don't just say, sketch it. Normally, they give you bit by bit what you should do. But if they did what I did here with you for homework, and say, sketch it, where do we start? Shape. And again, this was a positive shape. So it's first increasing, then decreasing, then increasing again. Your second step would be to find your y-intercept, which is 12. It's actually that d part. Ax to the 3, bx squared, cx plus d, so the d part. Then I taught you to first go and find your x-intercept, which you do by saying log d. Y equal to 0, and the method is Bateman, yes. So we're going to have 0 equal to x to the 3 minus x squared minus 8x plus 12. And now that you know the technique, you know how do I then factorize this by using our Bateman, our synthetic division. So how does that work?
First write the coefficients.
First write down the coefficients. 1
minus 1 minus 8 and 12.
Okay, and what comes here?
2 the factor.
Something that you got where? From your calculator. Whichever calculator you have, you substitute the value of x in, so we can find it. You've got, which value have you got? 2. 2 or what? Just 2.
Just 2. Or negative 3.
Or negative 3. Okay, now let me write it like this, 2 and negative 3. Because now actually you're crooking it right, because your son has told you, your calculator has told you that those are the 2 values. So what you need to tell me here is which one do you want to use? 2. So that meant that x minus 2 was the factor, because this is actually the remainder and factor theorem. When you can get a factor, it goes in without a remainder. And that's why this should be equal to 0. So if you don't get to 0, after your calculator has confirmed that you should get 0, you made a mistake somewhere. The technique, and unfortunately it's again a 1, it doesn't matter what's there, it must come down here. Then the technique is multiply, write the answer of 2. Add gives you 1. Multiply gives you 2. Add gives you 6. Times gives you, which does give me the 0, so I'm very happy in myself. What does this represent? It represents the factors. This is a factor, the x minus 2, that you time with this quadratic factor, which are the coefficients are represented there. So it's x squared plus x minus 6, that's equal to 0. So basically you went from there to there using synthetic division. So this is your 6th type of division now. You have common, taking out a common factor, difference of squares, trinomial, grouping, sum and difference of cubes, and then when it's the cubic one, you need the synthetic division, the remainder and factor theorem, Bateman. Okay, so trinomial is actually James Bond and Bateman, they're both together in factorization. Right, so now that I do have this, can I say what the answers are already? Yes. Well, x is equal to 2, I do know that. But where does the minus 3 come from? Now, as we've seen in the previous ones, if there's only 2 x-intercepts, what should be the case? One of them should be a turning point. One of them is a bouncy if you're thinking about quadratic inequalities. But which one? You won't be able to see until you factorize. So one of them should be there. So you can go factorize, it's going to be x plus 3x minus 2, whichever way you do it, with James Bond or with your calculator. I need the factors, and that's where your next mark is coming from. So it would be for putting it equal to 0, for getting the factors and more factors, and then for your answers. So it could be that your marks were 1, 2, 3, 4, 5, 6. It's too much. Okay? But giving you an estimation. Which one is the turning point? The 2. The 2, the one that's there double, like you can remember. So actually, Last year we were doing a little bit of cubic functions inside of our quadratic inequalities. Okay, so this is then going to be also your turning point because there were two of them. So if we carry on, we still need to find the turning points. And for the turning points, what do we need to do? Put the derivative, which is the gradient, equal to, must make sense to you guys, derivative is gradient. So looking at any graph, the gradient would be positive, positive, less positive, less positive, less, 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 0. Then negative, a little bit negative, lots more negative, back to 0, positive again. So there's a gradient in every single point. Depending on the point's x value, you'll have a certain gradient, but the main thing is how come we use it for turning point? Because in the turning point, the gradient is 0. So this is worth a mark, knowing that for the turning point, you've got to do derivative and put it equal to 0. Now let's do the derivative. What would it be? 3x squared. How come? What's the story again? Exponent times coefficient, take 1 away from the exponent. Exponent times coefficient, take 1 away, exponent times coefficient, and the derivative of a number is 0. So then I've got a quadratic equation to go and solve. How? James Bond, and if it doesn't work, the quadratic formula. Does this one work? What are the answers?
X minus 2 and 3x.
And x is what?
No, x
Equals to negative 4 over.
x is 2 then.
Negative 4 over 3.
Thank you.
X is positive.
Positive 2. X is 2.
Right. So where did I get that from you? But where can you get it? From your new calculator? Or it gives you those answers. But you can't just write that. You're going to help me feel happy about it because you have to go say x minus 2 and you've got to go say 3x plus 4. Or, old school, do the James Bond. 1 times 3 and for 8, 2. Yeah, which will be 6 and 4. To get me minus 2, you've got minus plus, minus plus. X minus 2, 3x plus 4. Any which way, who knows what you did? Need the factors, need the answers. So those are the x values for your turning points. So I still need the y. Now you can, if you are in a stress situation, maybe you forgot that this is also the x-intercept. So how can it be the turning point? Because that means the turning point is 2 and because it's an x-intercept. Are you with me? If you forgot, what would you have done? Go back to where? Original sum, because this is a point on the original graph in which I have to say x to the 3 minus x squared minus 8x plus 12, and I'm substituting for x width. And it just takes me a while to go and calculate that on my calculator and get me an answer, please, of
18,5.
2. 1. Is it 2? Double check. Is it 2 or is it 1? So that the turning point is 4 over 3. Now guys, I'm going to draw 4 over 3. I'd also want to rather see it as negative 1 comma 3 3, and the other one then 18 comma 5 2. Have you checked it? That it's 5 2 not 5 1. They never deduct marks for rounding off here, so not a big problem. Can I now sketch it? Yes, we can. So if we need to go sketch it, we need the set of axes. We need the y-intercept that was 12. Who says that's 12? Remember, we're busy with sketch graphs. So I could give you 120. Doesn't matter, because you're not going to go according to scale. Your x-intercepts were 2 and negative 3, but you know that it should be turning by 2, and that's where I always put a little cross. It's up to you what your technique is. And then I still have to find the other turning point that was negative 1 comma 3, which is somewhere here. Are you with me? That's why I wanted to see it's -1 comma. So I can see it's between -1 and -2 or wherever it might be. So -1, comma 33 is about there, somewhere. And 18 should just be more than that, right? Somewhere there. No exact point. But draw it so that you can make a nice sketch for me. So that's -1, comma 33 and 18, comma 5, 2. So that my sketch starts where? Please remember, that's the shape. And this is a turning point. So I must come from somewhere down there to make it that shape that I'm looking for. So, up, turn, down, turn it, again. And this was the graph of it, which can be 12, 15, whatever marks they wanted to allocate for that. Let's see if we continue, and I'm asking you to find the point of inflection. So if my question carries on and I'm saying, please find me the point of inflection, or the inflection point. The point of inflection I taught you was where? Exactly between the two turning points, and where exactly? Right in the middle. So if you take those two x values and you get right into the middle of it, and then take your two y values, which is 18, comma, and 0, and get right into the middle of that, that would be your point of inflection, and there's nothing wrong with that technique. That's one of them. So the point of inflection then would be -1, comma 33 plus 2 divided by 2. Does that make sense? The two x values of the turning points divided by 2. So y, 18,52 plus nothing divided by 2 is going to be 9,26. And this one?
0,34.
0,34 is rounded off correctly. And I'm done. But then I'll also show you there's another technique. If you want to find it with an alternative technique, you remember you are alternative queens and kings. Or you could have done it by saying for the point of inflection, that's where your double derivative is equal to 0. So now where's double derivative? How much I get double derivative? Obviously you've got to do the first derivative. Please don't do it again. You've already done it. So somewhere in your sum, focus on knowing that that's your first derivative. Maybe there was a 3 that you could divide before you got to your x-intercepts. That's not your derivative. First derivative, that's your gradient. So take the gradient, which was 3x squared minus 2x minus 8. It's unnecessary to write it again. And just do the derivative again, which is giving you 6x minus 2. But you only put it equal to 0 once you know you're looking for the inflection point. So what would the inflection point then be? Well, let me just save some space here. So x is going to be 2 over 6, which is a third, right? Right? 0,33? 34? What's happening here? It's a little off. It's not wrong, but there is a rounding difference. Not a rounding error, a rounding difference. Because when I rounded it here, I could have had more decimals, it would have been more accurate. So that when I add it here, it will also be more accurate. Are you with me? But that's close enough, the 0,33. But once you have the x, where's your y? How did I get there? Substitute it back. So that you didn't have to do there, but you're going to go back and say y is equal to exactly what you did, but now with a third. And your answer? If I'm correct, it was exactly the same, which is 9,26, which is just by accident. It could have also been off by 1/10 or 1/100 or whatever, and that's fine. Okay, different techniques have a difference because of rounding. Not because it's an error, it's rounding. So you would still have your inflection point, which would be a third and 9,26. Does everybody agree with me on that? The 9,26. Then I need to carry on. I need to also then tell you about concativity. that changes. Now, I already said to you that the point of inflection is where the concativity changes, right? So right there in the middle, which is 0,33, which is close to the x-axis, and 9 comma, which is a little bit down, somewhere there. And please don't look at my sketch because it's not according to scale. If it's exactly in the middle, mine looks a little off because it's not according to scale. You're finding this. So what happens at the point of inflection? The concativity changes from concave downwards to concave upwards, or concave just down to concave up. They can call it also that. Yeah, that's it, what I can think about. But then I can also ask you another question. So if I ask you, where does concativity change? You should know that's the point of inflection, and this is the way that I get it. If you had the sketch and you have all the information and you just want to go to the x values and get the half, that's perfect. But it's going to happen that I'm going to give you just any random sum and say, find me the point of inflection. Then you've got to know, but then I've got to do first and second derivative and find it this way without doing the whole thing, finding turning points, etc. Okay. One last thing about the concativity then is if I say, what is concativity in a specific point? Find the concativity in a specific point. Say, for instance, I chose here. Let's choose some nice numbers like -2. If x is -2, what's the concativity in that point? It's concave down. So you'll remember me forever for this. Concave down means you throw the water out. Do you see it? And concave up, you're keeping the water right. So in a point, if I look at the concativity there, it should still be down. And anywhere here should still be up. But there's a checkpoint. So without a sketch, I can ask you, for instance, find the concativity in the point where x is, let's say, -2. What's your answer going to be? Down. But you don't know that because you haven't sketched it. Are you with me? So if I want to find the concativity, you're still going to find it using your double derivative. So what was the double derivative? It was 6x minus 2, but it's only equal to 0 in the inflection point. In other points, when x is equal to, for this instance, this case, you can find the concativity using that. Now, if you do substitute it, what's going to happen to it? You're going to have 6 times, giving you what? -12, -2 gives you? Now here's the lesson. If the double derivative is less than 0, it's concave down. Have you got it?
Yeah.
Excellent lesson. So this means it's concave, downwards, down to the bottom, something like that. And if I chose any other one, say for instance, let's choose 4 over here, or 1, or whatever, just after the point of inflection, anything here will give me a positive because it's keeping the water. So let's look at this one. 6 times 4 minus 2 giving me 24. The fact that it's 22 means nothing. It's the fact that it's positive. If it's positive, it's concave. Nice to remember it that way. But everything about concativity, upwards, downwards, positive, whatever, is all to do about your point of inflection, which is your double derivative. Right.